Hi everyone, welcome to my YouTube channel. I hope you are doing extremely well. So guys, today is our day 11 in our NEET Code 150 DSA question series, and I hope that you guys are being consistent, you guys are solving the problems daily. So because see here, our main motive is definitely to solve the problems, but on top of that, to build this habit of solving problems, to build that consistency, right? And once you repeatedly solving the problems, then somehow एक habit हो जाएगी आपको कि हाँ, I have to anyhow do the problem daily. So as of now, along with the problem solving thing, we are doing this habit building thing also, right? So that's why I'm saying don't break the streak, because once that habit is within you, then anyhow you yourself would be solving the problem. Now then in that case you don't need any external motivation or something, because that habit would be developed, right? So that's what I'm again and again pushing this thing, that you have to solve daily. So that is the thing, right? So today's problem is to some second input array sorted. So if you remember that in our array and hashing topic, we solved this problem to sum, right? Now we can say this is an extended version of the same to some second, but condition here is that input array is sorted. So yes, we will go through the problem statement, understanding it, the logic part, the code part, everything. So let's get started. So the problem says given a one indexed array of integer. So you know that generally the indexing starts from 0, right? Generally, so like what? Indexing starts from 0 itself, right? But here they have mentioned that here we are having one indexed array of integers, means indexing is starting from 1. That is already sorted, okay, in non-decreasing order. Find two numbers such that they add up to a specific target number. Let these two numbers be numbers index 1, here you can see, and numbers index 2, where 1 less than equal to index 1 less than index 2 less than equal to numbers dot length. Then obviously these two numbers that we're going to take, they'll be lying in this array itself, right? So you have to return the indices of the two numbers index 1 and index 2 added by 1 as an integer array index 1 index 2 of length 2. The tests are generated such that there is exactly one solution. So they have clearly specified that there is going to be just one solution. And you may not use the same element twice. So we cannot use the same element twice, right? So whatever, let's say the target is 4 and we are having 2, right? So just 1 2 is there and rest elements are some different. So we cannot just take this 2 twice and 2 plus 2 equal to 4. No, that does not make sense. So they are saying that both the elements should be on different index. That's what, right? So your solution must use only constant extra space. Okay, so they are saying that constant extra space should be there. So let me help you with the in an understanding with the help of an example. So here we are having the numbers array consisting of the elements 2 7 11 15 and target is 9. So here if you will see, so 2 plus 7 is giving us the target, that is 9. So we are returning the indexes. So indexes, remember, this is what? One indexed array. So that's why 2 is not going to be set to be on index 0, but on index 1. So index 1, index 2, we are having 2 and 7. So that's what we are returning, right? Similarly, here if you will see, so 2 and 4 is, the sum of 2 and 4 is equal to that of target, 6, right? So on what index they are? So 1 is on index 1 and 4 is on index 3. So 1 comma 3, that's what we are returning. Now, similarly, if example 3 you will see, so numbers equal to minus 1 comma 0, target is minus 1. So minus 1 plus 0, so index 1 comma 2 we are returning. So here constraint, you can just have a look on that. Constraint is very important that you should consider, right? So now question is clear. Now we will think that, okay, how to solve this particular problem. Well, if you remember, we already solved this two sum. The problem is same only, right? Is there any difference? See, those who have solved this problem, what I'll be doing, if you haven't solved this problem, then first solve this problem and then hop on to this one, right? I'll be providing the video link in the description for this particular problem. We have already solved this one, right? So the problem, these both problems are same only. The only difference is that here the array is sorted and here array was not sorted. So you can solve this particular problem by using the approach that we used for solving this particular problem. Now I'm not going to repeat the approach again. If you want to know that approach, So you can just watch the video where we have discussed this particular problem. So in this approach, we have used, because array was not sorted, so we have used extra space. We have used a map here, right, to solve this particular problem. But here they have clearly specified that you cannot use any extra space. This should be constant. And obviously, if array is sorted, then there should be some reason, no? I mean, some advantage you have to take for this particular situation or scenario. It's not like if you're solving the same way only, then what is the difference between both the problems, right? So here, one thing logically, if you will think, so let's say array is sorted. So let's say if I'm having one pointer here, one pointer at the starting index and one pointer at the end index, right? And I start adding the elements which is being pointed by I, which is at the starting index, and j, which is at the end index. Let me write here. Let me write here. I and j, right? So if you will add 2 and 50, array is already sorted. So what we will get? We will get 17. It means it will give us an idea, okay, 17 is what? 17 is greater than that of target, right? It means what? That we have to shift this, matlab we have to move in this direction, because the array sorted means here we have the chance of getting, obviously will be getting the smaller element so that our sum can reduce, right? We are sure about this. So what we will do? We will reduce the j. We will do j minus minus. Now again, we will, and along with that, obviously, we will check if it is equal to that of target. So there itself, we have to stop and, return the answer. So 11 and 2, 11 plus 2 is going to give us what? 13. 13 is still greater than that of 9. So what we can conclude? We can conclude that it is greater, no? So still we have to move further in the left side, because obviously when you will move in the left side, so some will be reduced, some will reduce, right? And we, because the sum as of now target is greater, no, and we want it to be reduced. So again we will do j minus minus. Now again we will do the summation. So 2 plus 9, so we 2 plus 9 is going to give us the target. So we have got the two elements which are equal to, like, whose summation is equal to that of target. So we are going to stop at the time and we are going to return the indices, right? Right, so that would be our approach. So let's say if this was the scenario, if the target is 22, the target given to us is 22, and again I is at the starting, just I'm taking one other example, and I is at the starting and j is at the end. So we will do the summation again. 15 plus 2, 17. 17 is what? 17 is smaller than that of the target. It means what? That we have to move in the right side, because array sorted means the element which we will get in the right will be obviously greater than that of the element on which we are currently, right? So what we will do? We will increment the value of I, right? And j will remain at its place only. So again, we will do the addition. 15 plus 7, that would be 22. So we have got the target indexes. So we are going to return them. So yeah, that is what our approach is. The same thing we are going to do. So that's what we have implemented here, is that first we have taken, this is the length of our array numbers, and st is basically pointing to the starting index, and lst is last, which is pointing to the last index. So we will continue, because see, we don't have to consider the same index twice. So obviously we will continue in our loop while starting index is less than that of the last index. And first thing that we will check, that if we have got the target, right? So if numbers st plus numbers lst is equal to target, so we have to return the indexes. And plus 1 we are doing in both these values, because here they have set the index, our array indexes, one based indexing is there, right? Else, if the other possibility is that the summation of both these elements is greater than that of target, if it is greater, then what we will obviously do, we will try to reduce the summation. Then we will move in what direction? In left direction. So we will do lst minus minus. Otherwise, the scenario would be that it is the target is lesser than, the summation is lesser than that of the target. Then in that scenario, we will move in the right side direction. So we will do st plus plus, right? So like that, it will continue. At the end, we have just simply added a return statement, right? So yeah, this was the approach to solve this particular problem, the two pointer approach for solving this particular problem. Now here you can see we don't have, like, we haven't used any extra space, and obviously we are satisfying the requirement that they have specified here. And if talking about the time complexity, so just let me know what would be the time complexity for this particular problem. Comment what is the time complexity for this particular problem. Thank you so much for watching this video, everyone. Make sure to maintain the consistency. See you tomorrow with the next problem. Bye bye.